Hello class 11. What we are going to discuss in today's video is a topic that you've already dealt with in your junior classes, starting from class 6, class 7, class 8, of course class 9, and in a greater detail in class 10. And therefore the topic is work, power and energy. Such a very familiar topic, isn't it? Alright, so what we are going to do in this particular video is I'm going to give you an overview of all of these three topics today. Okay, so very briefly we are going to discuss about all of these three topics. We are going to look at the basics of each of these three different topics. Alright, then after in the upcoming videos what we are going to do is we are going to look at some new topics that are there given in this particular chapter in the book. Alright, so let us therefore start with work. Now, what is work? Now, work is said to be done when, of course, there is a force acting and there is some displacement produced by that force acting. So, if there is a force acting and the force acting produces some displacement on the body, we say work is done. So, here is the piece of chalk, a body, okay, a force is acting and a displacement is produced in the body. Okay, so whenever the body gets displaced due to an application of force, we say work is done. And how do we measure work done? If W is work done is the product of the force acting, and if S is the displacement and the displacement produced in the direction of the force. We measure work done by multiplying the force acting on the body and the displacement produced in the direction of the force. So S cos theta is the displacement in the direction of the force, where theta of course is the angle between the force and the displacement. Now since both force and displacement are vectors, so work done can also be written as F dot S. So to say, work done is the dot product between the force and the displacement. We discussed about this when we actually discussed dot product of vectors. Now to see how S cos theta is the displacement in the direction of the force, let us discuss an example. Say you have an inclined plane and the angle of inclination of this inclined plane with respect to the horizontal of course is theta, and we have a body over here having a certain mass. Now what we do is a force F acts on the body. So you can see the direction the force is along the horizontal itself. So this is the force acting. Now what happens to this body? Due to the force acting in the horizontal direction, the body obviously is not going to move along the horizontal because you have an inclined plane. So what happens? The body moves up the incline. So say after a certain time the body reaches over there, such that the displacement produced is S. S is the displacement produced. Now you can see S is in this direction. S is in this direction. So this is a displacement S such that the angle between the force and the displacement is theta. Now what do? What we do is we resolve the displacement of course into two mutually perpendicular components, but we do not need the vertical component, so to say. What we are only interested in is the component of the displacement in the direction of the force. So the component of the displacement in the direction of the force would be how much? It will be S cos theta. So to say, S cos theta is the displacement in the direction of the force. So therefore, work is measured by the product of the force acting and the displacement produced in the direction of the force. Remember that. Okay, because of which of course we get this equation, get this form for work done. Now, unit or units, of course joule denoted by a capital J, and this is the SI unit. Ergs or erg, simply this is the CGS unit. Now if you have to find the relation between them, you can do that yourself. 1 joule is 10 to the power 7 ergs, don't forget. Okay, so these are things that you learned in class 10, up to class 10. So you need to know how to derive this relation. Remember that class 11. So this is about work done. The next topic that we're going to discuss is energy. I hope I can, erase this. You can pause the video, of course. So let me erase. So very quickly, energy also. So energy. Now what is energy? Energy is the ability or the capacity to do work. The more work I can do, the more energy I have. The lesser work I can do, the lesser energy I have. In fact, what is seen is work and energy are one and the same thing. Because like I told earlier, the more amount of work I do, I actually spend an equal amount of energy. The lesser work I do, I spend a lesser amount of energy, but equal to the work done, remember. Okay, so therefore work and energy are one and the same. To give you another example, I have this piece of chalk. This piece of chalk is being pulled by all the while by the force of gravity. It is being pulled by the force of gravity. So against the force of gravity, I want to lift this piece of chalk to a greater height. Alright, so what do I have to do? Me, I meaning the external agent, me the external agent, okay? So, me the external agent, I am doing work against the force of gravity to take this piece of chalk to a greater height. So which means obviously I have to do work against the force of gravity. So the amount of work that I do on this piece of chalk to take it to a greater height will be stored in this body as its potential energy. The more work I do, the more potential energy, so to say, is stored in this body. Okay, and when I say potential energy, obviously yes, I am talking about gravitational potential energy, because there is another form of potential energy also which you already know, that is the elastic potential energy. Alright, so do remember work and energy are one and the same thing, and energy is defined as the ability or capacity to do work, and so therefore they have the same unit, which is Joule. Joule is the SI unit, also that for energy. But of course, erg is not the unit for energy. What are the other units? The other unit is calorie. Calorie is not the easiest unit, of course, but calorie is a unit which is used basically with respect to heat energy. Alright? Now, the other forms of energy, of course, kilojoule or kilocalorie. You have kilocalorie also. By the way, 1 calorie is represented by small cal. So 1 calorie is almost equal to, this is the symbol for almost equal to 4.2 joules. There's a relation between calorie and joule, remember. You have kilocalorie also. What are the other units? You have watt hour. Okay, this unit you get from the definition of power, because joule can be written as watt second. Watt second means joule, do not forget that. So let me write it over here. Capital W represents watt, small s represents second. So watt second means joule, do not forget that. So watt hour you have, so this is capital W, small h, watt hour. You have kilowatt hour, small k, capital W, small h, kilowatt hour. In class 10 itself, you've learned to find the relation between watt hour and joule, kilowatt hour and joule. You can try doing that here also. So these are the different units. Of course, there is another unit also which is called an electron volt. Remember, electron volt also is a unit for energy. This is denoted by a small e, capital V, and the relation is 1 eV is 1.6 into 10 to the power minus 19 joules. Okay, basically we will talk about electron volts. The unit electron volts we will need once we reach class 12. Okay, 1 eV is 1.6 into 10 minus 19. joules. So these are the different units for energy. Now let us look at power. So you can copy this. So I'm erasing it now. Okay, so finally let us talk about power. Now what is power? Power, if capital P denotes power, then power is work done. Work done divided by time. Or so to say, how do we read this? It is the work, or rather it is the rate of doing work, or work done per unit time. How much work we can do in a certain time is what is defined as power. Take for example, you have two persons A and B. Okay, A on my right hand and B on my left hand. So A and B can do the same amount of work, or does the same amount of work, so to say. Alright, but A finishes the work in a lesser amount of time, whereas B takes a longer amount of time to do the same work. Okay, so who has more work, or do they have the, they of course are doing the same work, but who has more power, or do they have the same power? Thing is, of course, A has more power than B. Why? Because although they are doing the same amount of work, A is finishing the work in a lesser amount of time. Alright, so therefore A has more power. So how much work you can do in a certain time is what is called power. Remember that. So if W is power, so what am I saying? If W is work done, then time is T. Okay, so you can write rate of doing work. Now talking about the unit of power, work is measured in joule. Time is measured in seconds, so it's joule per second, the SI unit, which is also called watt. And it is denoted by a capital W, this is the SI unit. Alright, so joule per second means watt. Okay, so joule means watt into second. So that is what I meant, watt second means joule. Okay, I believe you already know that. So watt, the other unit is kilowatt, of course. Kilowatt, small k, capital W, which is 1000 watts. You have megawatt or million watt also, you can see. Megawatt denoted by a capital M, capital W. This is also read as million watt. Now million has how many zeros? Million has 6 zeros. So 1 megawatt or 1 million watt means 10 to the power 6 watt. Okay, the other unit will be horsepower, capital H, capital P. Now 1 HP, 1 horsepower is how much? It is 746 watts. Okay, so these are the different units for work, and this is the overview for work, power and energy. Thank you.